The first thing we're going to look at today is linear patterns. We're going to use linear patterns so we don't have to write out each triangle in order to get the total. So these make it easier to just use an algebraic equation. So we're going to make a rule for how many matches and triangles make up if we wanted to get to a certain number. So right here we're just going to have the triangles. Now we're going to have the number of triangles. And then in the last column, we're going to have number of matches. So we're going to start out just with one triangle. So we know that's 1. And counting up these, so I have number of matches, or this could be sticks. So we're going to have 1, 2, 3. Okay, now we're going to keep going. So we make the regular triangle, and then we're going to make another triangle. So we have 1, 2, 3, 4, 5 lines now. And 2 triangles. And we're going to try this one more time and see if we can see a pattern start to form. So we have 1, 2, 3. So now we can add up. There's 3 triangles now. And there's 1, 2, 3, 4, 5, 6, 7 matches. So something that we can see is there's a common trend of +2 in between the number of matches per one triangle. Per 2 per one triangle. So now what we can do is we can see that that forms a pattern, and once we know the rule, we're able to jump numbers. So now we know that we can group these. The first group can be one group of 2 plus 1. The reason I did that is you see the 3 right here, and so we can do this and just do there's 2 groups of 1 plus 1. And for the next one, there'll be 2 groups of 2 plus 1. And then the third would be the same thing except for 3 groups of 2 plus 1. So this is kind of the same thing as having multiplication. So we have the 2 plus 1 here, so the second one would be 2 plus 2 plus 1. And the final would be 2 plus 2 plus 2 plus 1. Now the easier way to do this would be multiplication. And so we're able to go, this would be 2 times 1 plus 1. The next one would be 2 times 2 plus 2, and the final one would be 2 times 3 plus 1. Sorry, the second one should end in a plus 1. Now the number of matches is going to equal the number of triangles is 2 times 2 plus 1. So now that we have this pattern, we're able to jump into a number that we want to get to. So now that we've completed the diagram, I kind of rewrote the chart over here so you can see the number of triangles and the number of matches per set. And so now we have a few questions to answer. The first is how many sticks are in the next diagram? So if we were to do this again, how many would we have? So one way we could do this is just by drawing it out. So we have 1 triangle, 2 triangles, 3 triangles, and then a 4th triangle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is 9. So we're going to have 9 matches or 9 sticks in the next diagram. And so how many sticks are in the 10th diagram? So now that we know that before this was, the first one on here was 2 times 1 plus 1 equals 3, we can just add in a 10 instead of that 1 to get the correct answer. So this would be 2 times 10 plus 1 equals 21. So there will be 21 sticks in the 10th diagram. The final question we have is to write an algebraic sentence and to describe this system. And so going off of this, we know 2 is the number of lines aside from this original, and then this is the number of sticks right here. And then this will equal the total number of matches. So we're going to write 2s to represent the sticks plus 1 is going to equal the total number of matches. So 2s plus 1 equals the number that we need. So that will be our algebraic expression. So now we can use that for anything we might need. So let's say we wanted to do the 20th. We could go 2 times 20 plus 1 would equal 41. So now we know what the 20th would look like without going through each individual one. So this logic will be easy for students to understand, and it'll also save a lot of time in the process. Today we're also going to be learning about problem structures and strip diagrams. So far, addition and subtraction problems have been categorized in multiple ways. There are 4 structures we're going to be looking at today. The first is join problems. The second is separate problems. The third is compare problems, and the last one, the fourth one, is part-whole problems. What is important by using these structures is that students are able to explain what they did and why it makes sense in the context of the question. Using these visual diagrams means we won't have to be using equations. So for this problem, we're going to be using this diagram. Right here you can see it says join at the top, the line down the middle, and then the arrow from going from the start to the result. Now what we need to realize is that in join and separate problems, it's going to be different depending on if the arrow is going to move to the change or if the change is going to be moving to the arrow. So for right now, for the change, the arrow is going to be going towards the start because we're adding what's changing to the start in order to get the result. So for this, we're going to get our marker and add an arrow from change to start because that is the start, but we're adding the change to the start in order to get the result. Now we're going to do an example using this join structure diagram. And so let's say that Molly had 3 cookies. So Molly is starting with 3 cookies. So we have 1, 2, 3. Now let's say Billy is going to give Molly 5 cookies. So the change right here is going to be 1, 2, 3, 4, 5. Now since it's a joint problem, that means we're going to be adding. So the result right here is going to be 3, which is what Molly had in the beginning, plus 5 is going to equal our result. So for this number, it's going to equal these dots. So now we can count up these dots. 1, 2, 3, 4, 5, 6, 7, 8. So the result is going to be 8 cookies. So now we can fill in our block right here with 8. The next thing we're going to be doing is separate problems, and this is using the same diagram as the join, except for separate is to take from, while join is to add to. So this is our subtraction version. So the main change in this problem is that the start arrow is now going to the change instead of the change going to the start. So let's have an example for this. Let's say that Bob has $3. So we're starting out with $3. And Bob gives $1 to Sally. So what's the change going to be? It's going to be 1 because that's how many dollars he's giving away. So now, since this is a subtraction problem and the arrow's moving this way, that means we're taking away 1 from this. We know that 2 will be left. So the result will be 2. Another way we can write this out is 3 minus 1 is going to be equal to 2. So there are $2 left. The next structure we'll talk about is a comparison. So we'll be using this diagram to compare the differences between a larger amount and a smaller amount and finding the difference or finding the result from that. So let's say that George has 12 pennies and Sandra has 6. So this is going to be the larger amount. So let's say that this is George 12 pennies. Okay, and then we said that Sandra has 6 pennies. And so how many more pennies does George have than Sandra? So that is what's going to go here, the X, because we do not know what X is. But we do know that Sandra is right here, and she has 6 pennies. So one way we could do this is saying this amount less this amount equals the difference that we're looking for. So we can write this out by saying 12 minus 6 is going to equal X. Or we can also write this out by saying x plus 6, because this plus this is equivalent to this. So we can draw those arrows right here so that we know that this is equal to this. So x plus 6 is equal to 12. So now we can just solve this problem out by subtracting 6 from this side, subtracting 6 from this side, and we find out that x is equal to 6. So that's the difference. George has 6 more pennies than Sandra. The last diagram we're going to be looking at is a part whole structure. So in this you could see part equals the whole. So the equivalent of both parts added together is equal to the whole. So you could also call this a collection. So right now we're going to go over an example problem that states that there are 8 chocolate chip cookies and 8 sugar cookies. How many total? So how are we going to find out this number if we don't have anything in here? So the first thing we're going to do is move, we know part and part. So we can have 8 chocolate chip cookies, and then we know the other part is 8 sugars. We can also do this through dots. 1, 2, 3, 4, 5, 6, 7, 8. So that might be an easier way to count these up. And then we're going to also have 8 sugars. 1, 2, 3, 4, 5, 6, 7, 8. So how many whole? That's the question. So we have, let's say 8 plus 8 is equal to our whole. So we can also draw this out in dots. 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6, 7, 8 equals whole. So now we can actually add these up. So there's 8 on this side and 8 on that side. That means that the 8 plus 8 is going to be equal to 16 cookies in all. Now we're going to be moving on to our first problem. The problem states that William and Sally put 160 marbles in a jar. William put 83 of the marbles in the jar. How many marbles did Sally put in? So for this, we know the total and we know part of it, but we need to know the difference of what Sally put in, because we know William put in the 83. So right now I've already made this comparison chart and the difference is unknown. So we're going to label this the large set right up top. Because this is going to represent the 160 total marbles. All of this. And now we're going to label this section right here the small set, because this is going to represent the 83 marbles that William put in. And we're going to label this small set. And right now we know that these two line diagrams are going to be equal. And so these two strips represent 160. So knowing that, we know that this has to add up to 160, including the 83. So this is going to be our question mark, and this is going to be the difference. So how we're going to find this out is by subtracting the small set from the large set to get the difference. So we know right here that the large set is what we're going to start with, the 160 marbles, and we're going to do subtracting the 83, and that is going to equal our difference. So how we're going to subtract this is just 160. It's an easy way to write it out, minus 83. And we know that this total will equal 77. So knowing that the total is 77, we know that Sally put in 77 marbles in order to make 160 at all. So the difference is Sally put in 77 marbles. And so that solves our problem. 77 is how many marbles Sally put in.